Hi, so I'm going to introduce the sigma notation in this video, and let's get started. Now, in maths, we always like to use short, a condensed notation or a concise notation. So let's just start with an ordinary sum of integers, say 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay. If we wanted to write this in the most concise notation, I will say use the sigma notation, okay, pronounced sigma, okay, and that's a Greek alphabet. It's the uppercase sigma. There is another lowercase sigma, okay, so that's the uppercase sigma. The lowercase sigma looks like this, okay. So there are two types of sigma, uppercase and lowercase. We use the uppercase sigma to show that we're going to do a sum. Now, I could use a dummy variable, okay? So the dummy variable, just say, like for instance, I can call it J, all right? J equals 1 is the starting value. So that's the starting value. All right? And it can end, in this case, it's ending, the ending value is, there are 6 terms, and then you would say that is 6. And it's not the actual value of the term, as you will see in the next example, it's the number of terms, okay? The starting value to the ending value, and then you're going to just say, when J is 1, the term value is also 1, okay? So you're going to add just J, okay? I could replace it with something else. I could write, instead of J, I could write N. N is equal to 1 to 6, and then I could say N, okay? Or I could, that's why I call it a dummy variable, okay? It's just a variable that's being used to generate those values. Let's look at another one, okay? This is a very easy one. It's so easy that it might cause confusion. So let's start with something else. Now, let's say I wanted to do 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus 7 square, or something like that, okay? I would write this as sigma. Let's use the dummy variable I, because it's a dummy variable. You can use anything. I could write 1, and then I could write 7, okay, and then I could write I squared, right? So that is the same as that. Now, what if it didn't start with 1? Let's say it started with 2, okay? 2 square going up to 7 square. I could easily replace this with 2. And that's what it means. This just means the sum of terms. Okay, so that is how we use the sigma notation. Let's go with a third example, another easy example. Let's say I want to do 1 plus 4 plus 1 plus 6 plus 1 plus 8 plus 1 plus 10 plus 1 plus 12 plus 1 plus 1 over 4 plus 1 over 6. It's late in the afternoon, sorry. 1 over 4 plus 1 over 6 plus 1 over 8 plus 1 over 10 plus 1 over 12 plus 1 over 14. Okay, now I wanted to add this. Okay, I need to find something that keeps going up by 2. Okay, in maths, normally for odd numbers, we would say 2n. 2n is even number, right? And 2n plus 1 for odd numbers. Okay, so all even numbers go as 2n, and odd numbers go as 2n plus 1, or it could be 2n minus 1. Okay, 2n minus 1. Okay, so these are odd numbers. Okay. Now, if I wanted to write this as a sum, okay, I can say, well, it's going up as an even number. So there has to be 1 over 2n something. N is my dummy variable. I'm going to start with n is equal to 2, because 2 times 2 is going to give me 4, right? And then I'm going to end with the last value of 14, right? So 14 is 2 times 14, or 2 times 7 is going to give me 14, right? And then here I have 2 times 2, right? So I could write that as 2, n is equal to 2, right? And then put 1 over 2n, and then on the top, I'm going to put n is equal to, n, this is the starting value, and that's the ending value is 7, okay? So what does that mean? That means I start with, when n is equal to 2, I have 1 over 2 multiplied by 2, okay? This is when n is equal to 2. And then plus 1 over n is equal to 3. 2 multiplied by 3. Okay, so this is what that means. That means n is equal to 3. And then plus 1 over 2 times 4. Okay, so n is equal to 4. So what is n? N is an integer. That's just taking continuous values. N is equal to 1, 2, 3, 4, 5, 6. Okay, so that part we are going to assume in all these sigma notation that n is going to go up by one number, one integer. Okay, and you can decide where the starting is and where the ending is, but n has to just go up by 1. That's what the sigma notation is used for. Now, where do we use this most often in our course? We use it in the binomial expansion. And we know the binomial expansion is a plus b to the power of n is equal to n choose 0, a to the power of n, b to the power of 0, plus n choose 1, and it's got a pattern, n minus 1, b to the power of 1, plus n choose 2, a power n minus 2, b to the power of 2, plus, and then keep going on, choose some random number r, n choose r, a to the power of r, b to the power of n, a to the power of n minus r, and b to the power of r, and this keeps on going. And where does it end? It ends at n choose n, a to the power of n minus n, which is 0, b to the power of n. That's where it ends, right? So if you wanted to write this as a sigma notation, we could try to write this as a sigma notation. A plus b to the power of n is equal to, in every term, there's this n choose, n choose, n choose, n choose, okay? So that's going to be our first port of call. We're going to say n choose. Where does it start? It starts with 0, 0, right? And so that's the first thing that we're going to do. We're going to say, okay, we have the n choose, right? So we're going to do that as sigma. Everywhere there is n, so we're going to say n choose. I'm going to use a dummy variable here because this is 0, this is 1, this is 2, and so on and so forth. So I'm going to use some kind of a dummy variable, okay? And what is the dummy variable? I'm going to make my life easy and choose r as the dummy variable, okay? I could use I or J or A or B, who cares? But well, not A or B, because A or B is in the binomial expansion. Anything else? I'm just going to get a little lazy and say I'm going to use R, okay? Because it's a little efficient, okay? And then A to the power of n minus R, right? And then b to the power of r, which kind of is the same as this term. If you've noticed, it's the same as the term over here, right? It's the same term. So, and now I can choose where I want to start counting. I can choose that r starts from 0 and r ends in n. Okay, what does it mean? When r is equal to 0, I get n choose 0. This is the dummy variable I'm choosing, okay? So when r is equal to 0, I get n choose 0, a to the power of n minus 0, okay? And then b to the power of 0. Plus, the next one is r is equal to 1, okay? So n choose 1, a to the power of n minus 1, b to the power of 1. Plus, okay, so every time your dummy variable takes the next integer value, you generate the next term of the sum or the sequence or the series, right? So binomial expansion is a sum of terms, okay? So if you keep on changing the dummy variable by one integer value, you get the next term, right? So n choose 2. and that is when r is equal to 2. Okay, so every time you have, this is when r is equal to 0, this is when r is equal to 1, this is when r is equal to 2, and so on and so forth. So a to the power of n minus 2, b to the power of 2. Okay, so that is the general term in the binomial expansion. Okay, now the binomial expansion a plus b to the power of n has n plus 1 terms. Okay, what does that mean? If I have a plus b to the power of 3, I have 4 terms. Okay, you can check that later. Okay, a plus b to the power of 4 has 5 terms. Okay, and so on and so forth. Okay, so since we have so many terms, if I wanted to count the nth term, okay, if I wanted to count the nth term, okay, or if I want to say the first term, the second term, the third term, the fourth term, okay, the first term in the binomial sequence has a 0. The second term has a 1. The third term has a 2. What do I mean by that? The first term has a 0 here and a 0 there, okay, and a 0 there. The second term has a 1 and 1 and 1, okay? So if I wanted to call these terms term 1, term 2, term 3, and term 4, okay? So for instance, I wanted to call this term 1, okay? Term 1, okay? Or I can call it U1, okay? Or T1, okay? I could call this term 1 or U1 or term 2, T2, okay? I can call this term 2 or U2 or T2, okay? All these are suffixes. So I'm not doing U multiplied by 2, right? And this is term 3, or U3 or T3, and so on and so forth.